Assalamualaikum warahmatullahi wabarakatuh. We are group number 1, and the topic for our presentation today will be on multithreading. Let's start off with the introductions. My name is Muhammad Amar Shahmi bin Noor Nafi.
My name is Siti Aisyah binti Idris.
My name is Wan Darwisha binti Cik Wan Mamak Khair.
My name is Nur Izzati Inshirah binti Zaharuddin.
And I'm Nur Shahira binti Izan.
Here are the contents for today's presentation. We'll start with introductions, then move on to code sources, output, and finally the conclusion. Without further ado, let's get started.
Multithreading is a process of executing two or numerous threads simultaneously. A thread is a lightweight, independent, and the smallest processing unit that can run concurrently with other threads of same process. Multi-threaded program can run much faster than one single processor. Maximum CPU usage can also be achieved by reducing the amount of time the CPU is idle while the other thread is retrieving resources. Each thread follows a specific path of execution and runs parallel to each other. With this, another thread won't be affected when another thread is blocked or exempted and can run as usual. This can maintain the application to run more smoothly.
There exist three established multi-threading models. First is one-to-one multi-threading model. This model maps a single user-level thread to a kernel-level thread. This type of relationship facilitates the running of multiple threads in parallel. It provides more concurrency, which allows another thread to run when a thread makes a blocking system call. It also allows multiple threads to run in parallel on multiprocessors. However, the main drawback is the generation of new user thread must include creating a corresponding kernel thread, causing an overhead, which can hinder the performance of parent process.
So the last model is many-to-many models. These models will allow many user-level threads to be mapped to many kernel threads. These kernel threads can be run in a parallel on the multiprocessor. If there is a thread that performs a blocking system call, this model will let the kernel to schedule another thread for executions. But there is one drawback for this model, which is this model is difficult to be implemented.
And lastly, the third model of multithreading, which is many-to-one model. This model maps many user-level threads to one kernel thread, and it can be very efficient. But there are two drawbacks of this model, which is the first one, the entire process will block if a thread makes a blocking system call. And the second one, multiple threads unable to run in parallel on multi-core systems as a thread can only access the kernel at a time.
One of the real-time examples of multithreading is word processing program. The program checks the spelling of words in a document while writing the document. This is possible only if each action is performed by a separate thread. Another example is a browser that starts rendering a web page while it is still downloading the rest of the page. The program is divided into two parts. These parts may represent two separate blocks of code or two separate methods that can perform two different tasks of the same program. Hence, a processor will create two separate threads to execute these two parts simultaneously. Thus, a processor has two threads that will perform two different tasks at the same time.
Next, life cycle of multithreading. There are 5 phases in this life cycle, and I will explain one by one. We will go with the first phase, which is new. In this phase, the thread is created using by class thread class. It remains in this state till the program starts the thread, and it is also known as bound thread. Next, we will go with the second phase, which is runnable. In this page, the instance of the thread is invoked with the start method. The thread control is given to the scheduler to finish the execution, and it depends on the scheduler whether to run the thread or not. For the third state is running. When the thread starts executing, then the state will change to the running state. The scheduler selects one thread from the pool thread and it starts executing in the application. Next, for the fourth phase is waiting. This is the state where the thread has to wait. As there are multiple threads that are running in the application, so there is a need for synchronization between the threads. Hence, one thread has to wait till the other threads executed. Therefore, this is the state that referred as waiting state. And lastly, date. This is the state when the thread is terminated. The thread is in a running state, and as soon as it completed the processing, it is in that state.
So this is methods for our thread class. There is three methods. So the first method is start method. This method will start the executions of the thread and it will call the run method on the thread. The next method is sleep method. This will make the thread sleep, which means the thread executions will pause for the milliseconds provided. So for example, if I put sleep 100, that means it will make the thread executions pause for 100 milliseconds, and then after that, the thread will start executing back. So this method will help in synchronizations of the threads. The last method is run method. This method is for the entry point for the thread. So this is the code source for multithreading. In this class, which called as Guru Thread 2, we will have main method in it. It will create two different threads and start the execution. In line 3 until 5, we will create an instance of class Guru Thread 2 as thread Guru 1 and it will start the execution. So same goes to in line 6 until 8, we will create another instance of class Guru Thread 3 as thread Guru 2 and we will start the execution. So in the next code, we will create a class Guru Thread 3 where it will implement runnable interface. So basically, it will be implemented by any class whose instances are intended to be executed by the thread. So now we have two class variable, which is start thread class and the others is string class.
When a program starts, it will print out thread started. Then it will do an if condition to check whether class variable guru has any value in it. If it's null, then it creates an instance using thread class which takes the name as a parameter, then the thread will start. At this point, both thread guru 1 and thread guru 2 has started. Looking at the run class, we can see that in a loop, it will print out the counter and thread name. The loop executes 3 times, and in between, the thread is slept for 1 second. Because of this, the threads will take turn in creating an output. Instead of running 2 threads separately in a different class, this code runs both threads simultaneously, making it a multi-threaded operation. Let's take a look at the output here. Because we have 2 threads, thread started will be printed out twice. Then, we get the name of the running threads. It goes into a loop, printing the counter which starts from 0. Each time the loop is executed, the thread will be slept for 1 second. Hence, first we get Guru 1, then Guru 2, then again Guru 2 because Guru 1 sleeps here for 1 second, and then the next Guru 1, and again Guru 1, thread sleeps for 1 second, and so on and so forth until the loop has been fully executed.
With this, we can conclude that users will not be blocked when using multi-threaded system because each thread in the multi-threading process are independent and capable of operating multiple tasks at once, hence increasing process efficiency. Compared to process creation, multi-threading can be considered less expensive because each thread in the process share the same resources, making a better use of cache memory. Therefore, it is good to create multiple threads to operate multiple tasks rather than creating multiple processes. That's all from us. Thank you, madam.